Okay, good morning, ladies and gentlemen. This video is going to take us through 3 problems from Unit 5, Section 1, one-to-one functions activity. This is assigned on Tuesday, so I'm going to go over some of the problems, and we will require that you do the rest of the problems on your activity day. So I'm going to start off by looking at number 1. For us today, and we have this linear function f of x is equal to 6 minus 2 times quantity x minus 5. Is it 1 to 1? I'm going to find out what x value maps to -1. I'm going to find the x-intercept and y-intercept. Okay, keep in mind graphing calculators are allowed on this assignment, and they're going to be needed down the road. Also, calculators, they are allowed, and you want to definitely use them. Okay, first of all, is this a one-to-one function? Yes, and right off the bat, I can say this is a one-to-one function. Yes, since f of x is a non-constant linear function. This is a non-constant linear function. Linear functions that are not constants are always one-to-one. This is a non-constant linear function, and I can also say this function is always decreasing. Always decreasing. It's always decreasing since the slope of this is always decreasing since the slope m is equal to -2. Okay. What I'm going to do before I scale this, before I graph this, is I'm going to find the x-intercept and I'm going to find the y-intercept, and I'm going to use my calculator to do this because that's going to give me a better picture. I can scale my graph better, and my graph may be off. The scale is going to be off a little bit, but I'm going to use my graphing calculator to find the x-intercept. And what is the x-intercept? Well, what maps to 0? If I notice, I'm going to look at my graphing calculator. I'm going to put this in my graph. So put this in your graphing calculator and go to second 0, and you're going to find that 8, 0 is the x-intercept of that. And it would work in there too. If I put 8 into this, 8 minus 5 is 3. -2 times 3 is -3. -6. 6 minus 6 is 0, so that does work. And if I find the y-intercept, I just put 0 into this guy right there. If I put 0 into that, I get 6 minus 2 times -5, which is 6 plus 10, and that's going to be 16. 0, 16 is the y-intercept of that rascal. Okay? So I've plotted those. So it's not going to be really to scale, and that's okay. So now I'm going to plot the 0, 16. I'm just going to put it up here. The x-intercept is going to be 8, 0, and here comes my line. And I'm just going to sketch the line in green. And that's a decent graph. It's kind of a crappy graph, really. I'm going to try to come up with I'm going to use the line tool on that. I don't like picture, so here's going to be that'd be an okay graph right there. And I'll label this point right here as 8, 0. And this point right here is 0, 16. Notice it's off scale, and that's okay. So the key here down the road, this is 8, 0. Now I want to solve for A. I want to find out what output maps to -2. Well, -2, notice, is going to be down here somewhere. So that number is going to have to be whatever A is. It looks like it's going to have to be greater than 8. Let's see if it is. So let's solve that. Okie dokie. Here we go. So I want the output to be -2. And I want the input to be A. So I have -2 is equal to 6 minus 2 times A minus 5. Now I'm going to solve that simple linear equation for A, subtract 6, I get negative 8, is equal to negative 2 times A minus 5. I'm going to divide both sides by negative 2. That gives me 4 is equal to A minus 5. Add 5, and 9 is equal to A. And that makes sense because 9 is about right here. So what does that tell me? That tells me that f of 9 is equal to negative 2. And I would challenge you to put 9 in there. Well, if you can put 9 in there, 9 minus 5 is 4. Negative 2 times 4 is negative 8. 6 minus 8 is indeed negative 2. And this point right here is 9, negative 2. So I found that A that mapped to negative 2, and that A was 9. Okay? These problems linear are not too difficult. Okay? So let's go down here. I'm going to leave 2 for you. And I'm going to look at number 3, this quadratic function. This quadratic function has a vertex right here. We see that it does indeed have a vertex because this is in vertex form of 1, negative 4. All right? And we do know it opens up because 1/5 A is positive. So, I mean, I can sketch that bad boy right here. So that's 1/4. It does open up. So that vertex is 1 and negative 4. And this is a quadratic, and we're looking at this quadratic over its entire domain. So this certainly is not 1-to-1. And it is not 1-to-1, since no, not 1-to-1, not 1-to-1. Let's get this thing out of the way here. Not 1-to-1. Since any vertical line, any horizontal line, excuse me, intersects graph more than once. Okay? Hey, what are the x-intercepts? I'm going to use my calculator to find the x-intercepts, and I know there is a y-intercept, and I know there is 2 x-intercepts. So I'm going to find my graphing calculator. I'm just do my graphing calculator. I've already done that. I'm just going to write them down. Negative 3.4721, comma 0, and the other, that's this guy right here, and the other one is 5.4721, comma 0. Those are the x-intercepts. The y-intercepts, again, I'm going to use my graphing calculator. Just go and put 0 in, and that point right there is 0, comma negative 3.8. And I knew it had to be greater than negative 4 because that point right there is 1, negative 4. Okay, so these x and y intercepts are these quadratics with your graphing calculator, pretty easy. Don't forget your graphing calculator. Nobody's asking you to use the quadratic formula to find those, especially since we have our graphing calculator. Now here's the tricky part. I want to know what A's map to 1. Well, think about this, and this could be a good Google form question. What does A, where does A have to lie? Well, here's my 1. If I do a horizontal line right here of 1, do a yellow one, and I do a horizontal line, and I let that line be y equals 1, and I want to know where that function intersects 1, look at that. That A value is going to have to be greater than 5.4 and less than negative 3. So know that, because, and there's going to be actually 2 A's that map to 1. So let's find those rascals. So I want 1 to be the output, and I want A to be the input. This is the part of these problems that students traditionally have the most difficulty with, but they're not too difficult. So I want 1's going to be the output, A is the input. Now I simply solve this for A. I'm going to add negative 4 to both, add 4 to both sides, and I have 5 is equal to 1/5 adding the 4 to both sides. 1/5 a minus 1 squared. Multiply both sides by 5. 5 times 1/5 is 1. 5 times 5 is 25, is equal to a minus 1 squared. That tells me what squared is 25? -5 and +5. So that tells me that a minus 1 can be -5, or a minus 1 can be +5, because -5 squared is 25 and 5 squared is 25. So this tells me that if I add 1, a is going to be -4. If I add 1, a is equal to 6. And look, -4 is right here. -4 is indeed less than -3, and 6 is indeed greater than 5. So then I have these 2 points, -4, 1, and I could use my graphing calculator and verify this, and 6, 1. Okay, so that's number 3. I'm going to leave number 2 for you. Pause the video if you need to write this down. This is going to need to be part of your activity that you turn in. And let's see here, and I have number 4 is just a cubic, and I would say put this rascal in your graphing calculator. I'm not going to do this one for you. Use the graph and guess and check. You have your graphing calculator. You can find the x and y intercept. What I'm going to do is number 5 for you, and look, here's another quadratic. I'm going to end this video with number 5. Number 5 is a rational. And before I determine if it's 1-to-1 or not, let's graph that rascal. You should have learned how to graph this guy quickly. And you notice this thing has a vertical asymptote at 3. X equals 3. It has a horizontal asymptote of 1. I'm going to make the sketch y equals 1, Kerbillion over Kerbillion is 1, negative Kerbillion over negative Kerbillion is 1. It has a y-intercept, put 0 in, of -1, and has an x-intercept of -3. So this graph looks like this. It has to go up. And this particular graph, is it 1-to-1? Yes, it is 1-to-1. Why? Yes, 1-to-1. Since graph is always, what's the graph always doing? Graph is always decreasing. This graph is always decreasing. So it is 1-to-1. Graph is always decreasing, so that is why it is 1-to-1. Now, if I want to find, I found the x-intercept. I did find the x-intercept. The x-intercept is -3, 0. That's the only place this guy is 0, -3, 0. And I found the y-intercept, which was 0, -1. Now I want to know what maps to -5. Well, -5 down here is down here, folks. This is -5. So it's going to have to be an x value greater than 0, less than 3. So let's see if it is. So -5 is the output, and a is the input. I'm going to put a into the function. Multiply both sides by a minus 3, and I get this. -5 times a minus 3 is equal to a plus 3. I had scooted it over here to give me some more room. What I did was multiply both sides here by a minus 3. And so now I have -5a plus 15 is equal to a plus 2. If I subtract a, I'm going to get -6a. And if I subtract 15, is equal to -12. And that says that a is equal to 2. And right there is my 2 right there. So here's my 0.2 comma -5. And this doesn't seem important. It's going to be really, really important finding these when we start talking about inverse functions. So that's a short little video of 3 of the problems from the activity, and we would ask that you do the rest of the problems on the activity on Tuesday. All right, good day.